In our last video, we learned how to use the grouping function whose purpose was to assign a value other than null to any column in a summary row that wasn't being summarized. In this video, we're going to learn how to use the ranking functions. Let's take a look. Hello everyone, and welcome back to the SQL Server Series. This video is brought to you in reference to Joe Marach's SQL Server 2016 for developers. If you're interested in purchasing a copy of this book, then please follow the link in the video description below. The ranking functions provide a variety of ways that you can rank the rows that are returned by a result set. The row number function returns the sequential number of a row within a partition of a result set, starting at 1 for the first row in each partition. The rank function and dense rank function both return a rank of each row within the partition of a result set. If the rank of a distinct row is to be determined, the rank function adds 1 to the total number of rows, while the dense rank function adds 1 to the rank of the previous row. The entile function divides the rows in a partition into a specified number of groups. For example, if a result set returns 100 rows, you can use the entile function to divide this result set into 10 groups of 10. The order by clause of the ranking function specifies the sort order in which the ranking function is applied. Then, the optional partition by clause of a ranking function specifies the column that's used to divide the results set into groups. So let's take a look at our first example here. And the first one we're going to use is the row number function. So I'm just going to say row number. And that's going to be the first function we're going to have an example for. And then I'm going to select all from vendors. I'm going to step into my vendors table. And in here, what I want to do is I want to say row number over order by vendor name. I'm going to name that as my row number. And then I'm going to also grab my vendor name from the vendors table. And I'm going to run this query. And if we take a look here at our result set, remember it's going to start a new partition for every row, every new unique row that it creates. So if you see row number 1 here, vendor name is Abby Offices, and it's gonna go 1, 2, 3, 4, 5, 6 all the way down. Now if we were to run into another vendor name of Abby Office Furnishings, I'm sorry, I can't speak English, then it would be row number 1, 2, and then it would repeat back to 1 starting at American Booksellers. We can also specify the column that we want to partition it by. So let's take a look at another example using the partition by the optional parameter using row number. So I'll select all from vendors again, step back into my vendors table, and then I'm going to say row number and over partition by. That means here I'm specifying which column I want to partition. I want the row number to focus on partitioning for me. I'm going to say partition by vendor state, and then I'm going to order this by vendor name. And I'm going to name this as row number. And I'm going to grab my vendor name and my vendor state. I'm going to run this query. If we take a look at our result set, we see row number 1, the vendor name is AT&T, the vendor state is Arizona. Row number 2, the vendor name is Computer Library, and the vendor state is Arizona. And then if we come to row number 3, the vendor name is Wells Fargo Bank, and the vendor state is Arizona. And then it breaks out of that loop there. It stops at 3 and goes back to 1, and that is because our vendor state here, as you see, is no longer Arizona, it's now California. So for the vendor name Abby Office Furnishings, the vendor state changed from Arizona and it went to California, causing the row number to start a new loop in its partition, create a new partition, and start at 1 again. and then it'll go all the way down until it exits California. If we come down here at the bottom, it finishes California at row number 75, and then we move on to Connecticut, and it starts up a brand new partition, starts with 1 again. Washington, D.C. comes out. It's got 2 of those. I'm sorry, 3 of those. And then Florida's got 1. So the partition by optional parameter that can be used in this row number function can be used to specify which column you want to partition by using the row number function. If you don't include this optional partition by parameter, then it's just going to go ahead and partition it based on your order by, which would be the vendor name here at the very first query that we ran. So up here at the top, again, I'm just going to reiterate our syntax. So I want to make sure that we've got our eyes on the syntax here while our queries are going. So it's row number, and then it's over, and then after that it is your optional partition by clause, and then your order by clause. And of course, if you don't include your optional partition by clause, then it's just row number over your order by clause. Now let's look at the rank and dense functions. I'm sorry, the rank and dense rank functions. So the first example I want to use is I'm going to select all from my invoices table. This one's going to include an example of both the rank and the dense rank function together, because I want to be able to distinguish the difference between the two so we can understand it easier. So I'm going to say select rank, and then I'm going to say over, and then I'm going to drop in my order by clause, and I want to order by the invoice total, and I'm going to name that as rank. And then we're going to say dense rank over, and then it's going to be order by again, and it's going to be the invoice total, and I'm going to name this as dense rank. And then after that, what I want is my invoice total columns, and I want my invoice number. And I'm going to run this query. If you look at our results set here, what the rank function is going to do is every single time a new distinct row appears in your result set, it's going to do a +1 for the total number of rows, and the dense rank function adds 1 to the rank for the previous row. So if we see here our invoice total, which was our order by for both of our rank and dense rank functions, was 6.00 for 3 rows in a row. So those were not distinct. And so our rank, we've got 3 rank 1s and 3 dense ranks. And then as soon as it moves on to 9.95, we see our rank column say, hey, what row number are we on? It'll say, hey, 1, 2, 3, and then 4. So it's going to do a +1 here, and it's going to start off at 4. The dense rank function is going to say, we started off at 1, and we continued on with 1, and then once something new showed up, we moved on to 2. And then until something else new shows up, we're going to remain as 2, and then move on to 3 as our invoice total here. When it changed to 10, it moved to 3. And so the rank here, it stayed as 4 for 9.95 invoice total. And then as soon as it moved on to an invoice total of 10, it counted the rows again and did a +1 and got a 6. And then when it moved down here to the invoice total of 13.75, it counted the rows again and did a +1, and we got 9. So that's how these two work. Now, the one more we have to look at here is the entile function. So the first thing I want to do is I want to select all from terms. This would be an easier table to step into. And then then I'm just going to say terms description. I want that column. and then we're going to say end tile. Oops, sorry about that, little scrolling issue there. So we're just going to say end tile 2 over, and I'm going to put my order by clause, order by terms ID as tile 2. And then we're going to say end tile 3 over order by terms ID as tile 3. And then end tile 4 over order by terms ID as tile 4. And then I'm going to run this query. And if you see here, what we've done here with our first one, tile 2, is we've divided it into 2 groups. So we've got 2 groups here. Tile 2 has one for the first 3 rows, and then the last 2 rows are 2. If you look at tile 3, we divided it into 3 groups. And so we got the first 2 rows of 1, and then the next 2 rows of 2, and then a 3 to finish it off. And then if we look at end tile 4, which is tile 4, we've divided this one into 4 groups. And so we've got 2 1s, 1 2, a 3, and a 4. So you can easily use this function, to divide the rows in a partition into a specified number of groups. And when the rows can be evenly divided into groups, this function is easy to understand. Like, for example, if a result set returns 100 rows, you can use the end tile function to divide this result set into 10 groups. But the only time when this function gets a little difficult to use is when the rows can't be evenly divided. And so just something to kind of keep in mind when using the end tile function. So hopefully this information makes sense. If you notice in this video, I didn't include any background music. I think that maybe some of the music might throw some focus off from fully understanding in detail what's being explained. So I excluded the music from this video. But hey, say something in the comments down below if you guys think that I should put a little background music back into the videos. So that is all for this video. In our next video, we are going to step into database design and implementation. I promise we are this time. So if you're interested in the next video, we'll be beginning a new section in our SQL Server Series for database design and implementation. So head on over to database-tutorials.com and catch it. Have a good day and see you next time.